Hello, welcome back to BLENDERSUSHI Live Noding. In this episode, we're gonna do something that's a little bit unusual, a little bit fun. We're gonna try to use Sverchok to control some nodes inside node 3. So apparently you can do that. For example, look at this bunch of nodes. This is just like an input nodes. This is another Sverchok node 3 that I can simply control. I can control all of this using another node tree in Sverchok. So I'm controlling the numbers, like all of them, using Sverchok. And we can also control how they're kind of placed and position. And also, if you like, you can make the nodes kind of doing sine dance. So I can even animate it. So this is actually something that you can already do using Sverchok, and you can do this to any nodes, to any objects in 3D. But I kind of started to have a little bit of interest with Blender Python and how you can generate nodes using scripting. So the scripting part can be a little bit trickier, but for now let's just kind of understand the data and how you can access the data using Sverchok, because that's kind of, I think, kind of helped my brain to rewire the whole like the things like parameters that controlling this guy and parameters that controlling the position of the nodes. We have not connect the nodes yet, but at some point I'll also maybe use scripting kind of to connect the nodes together. But anyway, we can already do this. So if we can do this using Sverchok, then it's like a step easier for you to do Python scripting. I don't know. I like doing animations on objects. But anyway, so let's start. This is not. It's not super easy, but it's not actually that hard either. It's actually just kind of you just rewire nodes and then making things move. Sverchok dancing nodes. Let's start. Let's go to compositing and make a Sverchok. We're gonna teach the nodes to do some simple dance, the sine wave dance. We can call this the controller, and we can call this, we can make another node tree and call this the dancers. So for the dancers, I'll just have like an integer nodes. This guy by default is called, it has this name. The name actually is unique for each node. If I just duplicate a bunch of them, like make a 1, 2, 3, 4, they're named differently. So keep that in mind. The next thing I will do is actually to use Python console and maybe text editor. All this interface to help me kind of it's easier to explain and then to put everything together. Okay, this is the setup. Okay, now we start to generate the controller. We want to control. First of all, we want to get access to these nodes. So the way I kind of get there is to, first of all, we need to know what Blender Python or which BPY correspond to the position of the nodes. For how do we control the position of the nodes? For example, how do we change the parameter? By moving the nodes, we get this commands history, but this doesn't help much because it's like too much to understand actually. But if we are changing the parameter, this is easier, and this is exactly what we need. So I will copy paste that on into the text editor and have a read. bpy.data node groups called denser, and the node's name is int and integer 3. Okay, now we're getting somewhere. You know, this bpy.data, we can actually do that using the console. For example, bpy.data.node_groups, and you can see already that we have two node groups. One is called controller, the other one is called densers. With the densers, let's put this into a variable. Densers equal this bpy.data.node_groups denser, and we can actually access the nodes. And if I look at the nodes, node 0 is int 2 and then int 3. We can sort the nodes at some point, but for now we don't care about that too much. We can also ask Blender, okay, how many nodes do we have on the densers node 3? So we can use length of denser.nodes. This is all Python. Okay, whatever I'm typing here is Python. We are using a bunch of commands to access the data. Might be scary if you never use Python programming, but this is still kind of just a simple basic stuff, just querying the data and then asking the Blender, okay, how many nodes do we have? We have 4 apparently. And for example, we can say these nodes with index number 3, and we can find the locations. The location is these numbers there. I can change it like to -2254 192, and you see this guy is kind of shifting. I can actually change the number and make the nodes kind of moving like that. I can actually do it one by one. You see now the nodes are on top of each other because I make the position X and position Y here on the same spot. I can make modifications. So for nodes with index 0, the location should be, let's say, 120 or 150. So this is how, if you want to do it using Python, maybe this guy is like that, and one more guy. So because we have 4 different nodes. So you start to get the drill, and if I want to change the parameter, I can simply actually do similar thing. I think the attributes that we need is this int with underscore. I can change this to 150, so this guy become 150. I think I have one more nodes. There you go. So yeah, that's if you want to use Python, you can do it that way, and we can change the locations, we can change the parameter. So that's very easy. But now the next thing we want to do is to use Sverchok to do that. With Sverchok, you can really control many objects pretty easily, especially if you're using the object ID. We have object ID get, object ID set. We also have filter, object ID filter. These nodes are super useful if you are working with objects, and also any type of objects in Blender, actions, brushes, grease pencil, whatever. In the previous live noding, I already have another example how you can use object ID get and set to control the objects. But of course, in this case, we are controlling the node tree, these nodes. So we simply need to switch to the node groups. So now our mode is node groups. We're gonna get, by using these nodes, this is actually collecting all the data about node groups. Believe it or not, if you actually use a node and plug this guy in, you can see bpy.data.node_groups controller, bpy.data.node_groups dancer. This is exactly just like this. bpy.data.node_groups. We are getting data from the node groups this way using Sverchok. And the next thing we want to do is to get all the nodes. And in order to do that, you simply needs to first of all, you need to filter the name. So we do need this object ID filters. So the name is the dancers. Okay. So with the dancers, we have this data, and the next thing we want is to get the nodes info. Is it object set ID? There's one more actually. Object ID. Actually, set is kind of doing get, and this nodes is actually doing both. You either have input or you either have output. So it's a little bit, the name is a little bit funky. It's set, but it's kind of, we get the objects and we filter the objects, and then this guy can sort of display the value. So if we want to get all the nodes, we can do it this way using this kind of bracket and then colons. This is to get the list of all the nodes. The stethoscope kind of doing that as well. So we can actually get the name of the nodes, for example. You can do it this way. Get the name of the nodes, get the position of the nodes, or the location. There you go, that's the location of the nodes. Okay, cool. That's pretty clear. But be careful with this object ID set. You cannot have the input and output at the same time. You cannot actually, if you have this already viewing something, you cannot plug something here. Okay, be careful with that. Okay, so that's pretty clear. Now the next thing we want to do is perhaps use these locations and just supply our own data. For the locations, I was thinking, okay, maybe random vector. We have how many objects? We have 4 objects, so I switch the count to 4. If I plug that in, it's complaining. What's it complaining about? This is the other terminal. Object value sequence at dimension 0 should contain 2 items, not 3. 2 items, not 3. This is yeah, this is when things get a little bit confusing. Yeah, I think this is like a vector data type thing. In order for this to work, actually, we need to use this thing, locations, and then the colon and stuff. And then now you can see the nodes actually jump. Now we are actually controlling the nodes properly in the random fashion. So this guy is doing something clever here. Because if we look at the data here using the stethoscope, random vector is actually outputting a vector data. It's x, y, z. It's not like x, y. The node's position or the node's locations only expecting x and y, as you can see here. Just x and y data. You can that's all you need to provide. We are providing vector, but this sort of working fine. It's kind of doing it already. So we can have more. So we can have maybe 3 times 4, 12, 16, 20. Now we have 20. If I increase the number here, 20, if I need to refresh it, I think. Just need to scrub in the timeline, and then now this guy is updating. There you go. We are controlling the nodes already. They are all in random positions. Well, you can see it's really easy. Simply get get all the node groups, and then filter it out using this object ID filter, and then for every node's location, give it a random value, and then that's what we get. Cool. Okay, we can put it in random fashions. Of course, we can also arrange it in the grid. So for that, we can use line. Line is of course a generator in Sverchok that's kind of generating points in a line, like arranged in a line fashion. See, by default it's like in the x-axis. It's like putting the dots in the x-axis, so it's going that way. We can also make it going upward vertically if we reroute it using rewire. So if we switch x to y, this guy is now going up. So that's probably what we want for our nodes. We have 20 of them, and we can simply adjust the stepping. Now this guy is being aligned. Maybe 50 or 65. Now they are all aligned in vertically. You can make it align in the x-axis like this. Change the stepping to 150. So cool. You get that bits now. If we want to change the number of this integer, for example, we can do that quite easily as well, simply by telling it to get these attributes, int underscore, and then this guy, like that. The value should be an integer, so I'll try. Now this guy is complaining again about something. Integer doesn't support item assignment. This is a funny bit. Okay, this actually works. Yeah, that's actually interesting. Okay, now that this is working, we can perhaps use the vector out. Maybe we can use this value. Let me clear the grease pencil. Maybe we can plug that in, and there you go. That's what I want. See the value, the vector value, the y value is giving the number for each and every nodes here. It's kind of stopped at 1000. That's because of Sverchok limit on the integer value. Alright, actually, oh yeah, it's Sverchok limit on the this nodes. Actually, it's a limit between -1000 and 1000. I guess don't worry about that too much, because we can plug in our number and we can control the numbers already. That's actually our task is done. Basically, I will now make the nodes dancing in the sine wave pattern. Okay, that's also pretty easy to do. Let's do that real quick. We can already arrange it in the like vertically like that, so it's It's really simple. We just need to maybe kind of move it in the x-axis, in the x position. See, I can actually just use a randomized input and then randomize the x-axis here. See, that's already something you can do quite easily. See, for all the nodes, just randomize the x, and that's what we get. So if you want to have like a sine wave thing to work, you simply use vector math, and this should be an add, and use another vector here. And simply move it in x. There are many ways to do this. You can either do it this way, or you can just separate this vector and then assign a sine wave into the x. So math, sine wave, and vector in. The y should be from this guy, actually from this guy. I think I'm doing it correctly. The sine wave needs to be multiplied quite a big number because of the this position x and y is actually quite large. You can see it's a big number. I need to multiply it by 100 maybe. Sine x. This doesn't work because we need a value coming from the y. Still doesn't work. Let me check the stethoscope. So the x is all 0, 0, 0. The y is actually have this value. So the y value should be from here. I think we need to multiply the sine over here. There we go. Starting to get something. Oh, because the value is from here is too big. This one is too small. 100. Now we are talking. The next thing we want to do is to offset this value. There you go. That's the setup to make our nodes dancing. It's pretty easy, right? I think much easier than actually using Python scripting. Although, of course, whenever we want to do something like this, we need to kind of understand a little bit of Python just to get this this kind of Python functions, and kind of to understand which parameters we want to modify. And then once we get that, everything is pretty easy. So this is like the NT, this is the node 3, and this is the node's parameters that we want to adjust. Position wise is here, we want to do it. Actually, position is locations, and then yeah, that's if you want to use Python to do that, I can make the fonts larger. Once we have this, it's really simple to get to where we want. make this smaller, make it dancing. Oops. Alt A. If we want it to be controlled by time, we need to plug in the time into this guy. And Alt A. Okay, that guy is dancing now. Stuttering a little bit, maybe because I'm recording. Let's stop it. Actually, Sverchok, if we use time, it slows down a lot. If we don't use time, this is actually real time. So I don't know, maybe that's something that's maybe can be made a lot faster. See, as you're scrubbing, this is actually really fast, but if you're using time, it's slow, a little bit slower. So once again, I'll summarize the whole thing. First of all, I'm using the Python console, kind of deep down the information where to get to the data blocks and what parameter we can adjust using Python. Once we have that, we can jump into Sverchok. There are actually two ways to do this. You can actually use scripted nodes. Either of these, scripted node or scripted node lite, can actually kind of combine the Python and whatever like data you are generating, and kind of to do all this using just a single script node. In this case, we are doing it using object ID, and this is probably, this can be simpler for most people, but this part is a little bit tricky. But it's once again, if I explain it, I think it's simpler. Just get all the node groups and then you filter it out. Filter the node groups based on the name. Instead of controlling everything, you want it to specify node groups called tensor, and then you get all the nodes. You see this symbol, and then gets all the nodes, and then for the locations, because it's a vector 2 data xy, we need to use this symbol, and then all we need to provide is this value to generate the position for our nodes. And I'm using lines for that. Line generator, rewire the x to y, separate the vector, and you have this x, y, z, and you have the sine wave, kind of doing the sine wave, but it's doing it vertically. So that's why you get this. But yeah, you know, if we draw this guy, actually draw this, turn it into a line, you will see clearly that we are really drawing a line in 3D. See the line there? It's really big lines, but you look at it from the top, and if I run the playback, oops, no, I don't have the animations. If I offset it, you see the position of the nodes is moving the same, exactly like this line. So that's the secrets. That's the basic idea. I think I can make the lines even smaller just using vector math, and just scale the vector. So now it's a bit smaller, easier to look at. So that's the secret, okay? You can control anything that's x, y, z, or x, y using Sverchok. Actually, in fact, any kind of attributes you can easily control it using nodes now. Super, super easy. In fact, if you're like drawing something using grease pencil, you can also resample the grease pencil and kind of draw the nodes and control it the way you like. So let me check it one more time. Okay, yeah, I guess that's pretty much for this live noting. It's a long one, but it's a lot of information as well. If you have any questions, suggestion, or feedback, just let me know in the comment section below. Hopefully this one is interesting. If you are actually, if you're learning Blender, if you're learning Python, try using nodes as well to add. It's not adding the complexity, but actually, I think this actually helps your brain to rewire the informations, because sometimes looking at the text is not. If you're like a visual kind of person, looking at all this text is can be daunting. That's why we have nodes to do a visual, like a more visually doing things, and then with nodes you have all these parameters that you simply play around with, and then it's actually quite fun to do. Later on, if I have time, I will try to kind of make a bunch of video that just talk about coding and noding using Python and also Sverchok. I think this way of working is really can be more fun than actually just looking at this and then trying to make a tools, because eventually if you're like you understand programming, you can make like an add-on that does all this. But if you're like me, you like to do it visually, this is actually the way you want to work with. You can contain everything into a single node, and then I don't know, even though it's hard at first, but after a while this become much easier. Programming is a different thing, but all these actually kind of complement each other. So yeah, that's my point, I guess. Anyway, I'll see you in the next live loading. Thanks again for tuning in.